All right, so today we're looking at solving absolute value inequalities this time. So we're going to create equations and inequalities in one variable and use them to solve problems. So our essential question, what are two ways to solve an absolute value inequality? So first thing we're going to do, we're going to visualize a solution set of an absolute value inequality. So you know that when solving an absolute value equation, it's possible to get two solutions. So here we'll explore what happens when you solve absolute value inequalities. So we need to determine whether each of the integers from -5 to +5 is a solution of the inequality absolute value of x plus 2 is less than 5. Right? Yes or no for each number in the table. And if a number is a solution, then we plot it on the number line. So the first term we're going to look at here is when x is -5. Well, the absolute value of -5 is +5. +5 plus 2 is 7. Is 7 less than 5? No. Absolute value of -4 is +4. 4 plus 2 is 6. Is 6 less than 5? No. Absolute value of -3 is +3. +3 plus 2 is 5. Is 5 less than 5? No. Absolute value of -2 is +2. 2 plus 2 is 4. Is 4 less than 5? Yes. You can continue on from here. These should be the answers you get. This is all in between here. And again, you can check these yourself. But once we have found what our yeses are, we can go ahead and plot them on the number line. So it's all these values here between -2 and +2 are solutions. So now we want to determine whether these integers from -5 to +5 is the solution of the inequality absolute value x plus 2 is greater than 5. So same idea, but now we're looking, is it greater than 5? Well, again, starting here, absolute value of -5 is +5. +5 plus 2 is 7. Is 7 greater than 5? Yes. Absolute value of -4 is +4. 4 plus 2 is 6. Is 6 greater than 5? Yes. Absolute value of -3 is +3. 3 plus 2 is 5. Is 5 greater than 5? No. And so on and so forth. So it's very similar to what we found last time, except kind of the opposites with one key outlier here. And we can go ahead and plot these values then on our number line. So we want to state the solutions of just the equation absolute value of x plus 2 equals 5. So first thing we need to do, we need to isolate that absolute value. We do that by subtracting the 2. So that will get absolute value of x equals 3. So then that will give us solutions of x equals -3 and x equals +3. So how does that compare to our solutions we found in steps A and B? Well, if you notice, here when we have the -3, +3, not a solution. And as we scroll up here as well, when we had x equals -3 and x equals +3, that was not a solution there either. So when we relate those to the solutions we found before, they're not solutions to either inequality. Not solutions to either inequality. So if x is any real number on a number line and not just an integer, we can graph these solutions. So when we had values greater than 5, our values were here between -3 and 3. All these values in between here. Sorry, less than 5. Whereas over here we were looking at greater than 5. We picked all the values bigger than 3 and all the values smaller than -3.